In one of my previous videos, I had talked about the measurement of the length of an arrow using a centimeter scale. Let us recall the example once again. We had recorded a length of 4.33 centimeters and the uncertainty was 0.01 centimeters. Now, in 4.33, the first two digits, namely 4 and 3, were known, or in other words, we were certain about these digits. However, the third digit 3 was placed as an estimate of how much more than 4.3 centimeters. There is uncertainty in this position. This is an estimated digit, and we are doubtful about it. The number of significant figures is the sum of the number of digits we are sure about and one doubtful digit or the estimated digit. In this example, we are sure about 4.3. So that makes two figures and we have one doubtful digit. So that is an addition of 1. So the number of significant figures is 3. Let us take some examples and we will ignore the units of measurement throughout the video. 1.23 has 3 significant figures. 0.023 has 2 significant figures. 14 has 2 significant figures. But 14.0 has 3 significant figures. 0.0030 has 2 significant figures. 00045 has 2 and 203.450 has 6 significant figures. So how do you find out the number of significant figures? There are rules and we are going to look at them with examples. The first rule is very simple. Non-zeros are significant. So if there are no zeros in any measurement, then it is very simple. You just have to count the numbers. For example, 1.2567 has 5 significant figures. 5326 has 4 significant figures. 1.5 has 2. 53.67 has 4 and 88 has 2 significant figures. Confusion arises when there are zeros in the measurements. Now, zeros that are sandwiched between significant numbers are significant. For example, 1203 has 4 significant figures. 1001 has 4 significant figures. 12.063 has 5 significant figures. 11.0035 has 6 significant figures. 300.65 has 5 and 1.01 has 3 significant figures. Let's look at 1001 for example. Here, the ones in the beginning and the end are significant. So the 2 zeros between them, which are sandwiched between the 2 ones, will also be counted as significant. The next 2 rules are about trailing zeros. Now, if the number does not have a decimal point, then the trailing zeros, that is, those in the end, are not significant. For example, 30. It does not have a decimal. There is one trailing zero, but then it will not be counted. 3 is significant. Hence, 30 has one significant figure. By the same rule, 4500 has 2 significant figures. Now, how many significant figures are there in 10,307,000? Well, it has 5 significant figures. The trailing 3 zeros are not counted. However, the other 2 zeros sandwiched between significant numbers are counted. Hence, it has 5 significant figures. If the measurement has a decimal point, then the trailing zeros are significant. For example, 5.0. It has a decimal point. 1 zero after the decimal point is the trailing zero, so it will be counted. and 5 is significant. So 5.0 has two significant figures. 5.00 will have three significant figures. 5.030 has four significant figures. Note that the trailing 0 after the decimal and the one sandwiched between 5 and 3 are both significant. How many significant figures are there in 1000.80? The answer is 6. The number has a decimal point. The trailing 0 after the decimal is significant, and so are the zeros sandwiched between 1 and 8. Finally, the initial zeros or the leading zeros are not significant. For example, 0.00453 has three significant figures. The first three zeros, the one before the decimal and two after the decimal, are not significant. Note that this number does not have any trailing zeros. 0.04530 will have four significant figures. The figure has a decimal point, so the trailing 0 after 3 will be counted, but the first two are not significant. Hence, it has four significant figures. That's all about significant figures. There are some other issues. For example, what happens when you add, subtract, multiply, or divide various quantities that have different number of significant figures? Or how do you round off to a given number of significant figures? But we'll keep that for other videos.